This presentation discusses some of the key success skills that undergraduate students need to develop as part of their college experience so that they're able to be successful both as students and as future employees. The tips and thoughts in this presentation focus more on majors pursuing a computing or information technology major and to see how some of the skills learned in college translate to classroom success and also success in professional jobs in the future. Information technology is a rapidly growing field. It changes and evolves almost every day. Consequently, one of the most important skills in a computing landscape is to be able to quickly adapt to new tools, languages, and technologies. This includes working with different operating systems, maybe Windows, Linux, or Mac, working with different integrated development environments like Eclipse, NetBeans, Visual Studio, etc. And more importantly, work with debuggers and other software tools that can be used to troubleshoot software. A second important aspect is to develop good quality solutions. Generally, quality translates to reusability of the software so that the time and effort invested in developing a piece of software can be recouped and amortized by reusing the software systems. So, this requires very well documented methods and software that has been well tested and using automation to test the software so that it's easy to maintain in the future. Another important aspect of working in the industry is to be able to solve issues in a proactive manner. Reporting or working on issues after deadlines is typically a big negative because you're delaying product deployment or delivery of solutions to customers. Hence, if there are any issues, it's important to keep your manager or for in college your instructor updated about any issues your team might be experiencing. And of course, the last but important aspect of working in the industry is to work as a team player. This means you occasionally help your colleagues with troubleshooting, with learning new skills or new tools. But keep in mind, the idea of a teamwork is not to do each other's work or to plagiarize each other's work, but to just help each other to be successful at their specific tasks. This presentation is going to go over some of these skills in a little bit more detail. Let's start with the adaptation part. College courses are designed to expose students to a diverse set of concepts and skills. So that means we're not focusing on a specific job or a prospect, but to give you the necessary set of skills that will enable you to be successful in any type of job that you might pursue in the future. And of course, each of these courses and topics might use different programming languages to give you a broad exposure to the different tools and environments that we have today. And of course, we intentionally use different operating systems and different tools to give you exposure to the different kinds of things that happen in the computing landscape. Keep in mind this is intentional, and the intentional of diversity is to enable you to practice the skills that are necessary to learn how to adapt to change. So it is key here that you embrace the diversity because this diversity and being comfortable with adapting to change is one of the most important aspects that will help you in the long run in the computing industry. Adapting to change requires you to try and identify similar ideas or concepts. Many aspects of computing are very similar to each other, even though on the surface they might appear to look a little different. So, the key idea of adaptation is to identify and leverage similar ideas or concepts that are underlying many of these technologies. For example, a lot of the courses will use imperative programming languages like C, C++, Java, JavaScript, or Python. Keep in mind, all of these languages are very similar, and what you need to focus on is pseudocode. So, for example, if you look at a piece of Java code, or if you compare it to a piece of corresponding C++ code, you will see a lot of similarities in terms of expressions, loops, if statements, and calling methods. That is essentially the four things that all imperative languages do. So, once you are able to distill it down to pseudocodes, moving between languages is just becomes a matter of changing syntactical notations in the languages, and you'll be able to seamlessly move between these languages, and that is something that is expected in the industry. So, college education intentionally uses multiple programming languages to help you understand the similarities and the subtle differences between them so that you're successful at moving from one language to another. And in the future, you might be working with a completely different programming language, but the concepts would be the same, and you should be able to seamlessly move between these programming languages. Most IDEs that are used for development are very similar. Keep in mind these integrated development environments are the tools of your trade, so you have to be very comfortable with them. And keep in mind, most of these IDEs are very similar, may it be Eclipse or NetBeans or Visual Studio. They all have similar menus and icons. And the key idea to get familiar with them is to go read the menus, click on the menus, look at the options, look at the tools that are available there, and spend at least half an hour to 45 minutes just playing with the menus. And once you do that, learning that IDE will be very straightforward, and it'll actually save tons of time as you go through using and working with those software tools. Keep in mind each one of these tools have their own strengths, weaknesses, and quirks like any other software. None of these are meant to be bug free, because like other software are. They might have bugs and such, but understanding the quirks will help you work effectively with them. Keep in mind, none of these tools that are used by developers are tend to be designed as being idiot proof, because they're not designed for average users. They're not designed for idiots, so they are not idiot proof either. So keep that in mind as you work with a lot of these tools. And every IDE, doesn't matter which one you use, you should be able to use the debugger. Debugger is the most important tool for development. And this is like a firefighting tool. That means when your program is on fire or has a bug, this debugger is the only one that will be able to help you to step through your code, observe variables, observe multiple threads, and to be able to troubleshoot the problem in a successful way. So make sure it doesn't matter which IDE you use, you should always be able to use the debugger for the corresponding language, may it be Java, C, or C++. So when students are challenged to adapt, students or employees in work will often come up with excuses. They'll say, oh, I could have solved this problem in a different operating system. That means I can do it in Windows, but I cannot do it in Mac, or I can do it in Linux, I cannot do it in Windows, so on and so forth. They'll come up with these kinds of excuses. Or they'll come up with the excuse saying, oh, I could have done this in a different programming language. Or they would say, I know how to do this in Java, I just can't do it in C++. And that is another common excuse that you'll hear from students and employees. Or they would blame the IDE. They'll say, oh, I would have been able to do this in Eclipse. It's only Visual Studio that is preventing me from typing in correct code or avoiding compiler errors and bugs. So they'll start blaming different software tools and environments for their inability to adapt to some of these changes. So keep in mind, these are strawman excuses. What people actually end up hearing is that you're unable to adapt and reuse some of the concepts and skills that you've learned. And this is actually a negative. Instead, be proactive and seek help. Invest time to understand some of the tools that you're working with, keeping in mind that a lot of these tools will have their own quirks because they are not designed to be idiot proof. So this looks at some of the ideas and thoughts underlying the adaptation and learning new skills and concepts. Now let's look at the quality aspect in terms of developing good quality solutions. Your team and manager, in this case, your manager would be your instructor in a college setting, do care for good quality work. Keep in mind, when you start working in a team, you're not developing programs just for yourself, but you're developing programs that are going to be used by others. Quality of your solution translates to several different aspects. The first aspect is style. Keep in mind, style and formatting are the first things people see, and this is your first opportunity to make your best impression, because the first impression will be what people will remember. And when they look at code that's not properly formatted, there is no bigger turnoff than bad style. And poorly formatted code is an immediate turnoff for people, and they wouldn't even bother to look at the value of your solution if your code and your solution is not properly styled. Let's look at some of the issues with poorly formatted code. For example, look at this if statement. Why is this poorly formatted? Simply convert this to an English sentence in your mind. If you mentally convert it, notice how would you write an English statement without spaces in the middle? Instead, this sentence should have had spaces between each one of those words so that it's easier to read. Consequently, that if statement that was written before is poorly formatted. Instead, it should be formatted with spaces in the middle. And this kind of spacing, putting spaces in the right places, is absolutely vital. So, if you write code without putting spaces in the right places, nobody is going to be impressed with it. So, it is very important to ensure that you put and format your code correctly. A second aspect of formatting is also to have correct indentation. Typically, it's best to use spaces and not to use tabs for indentation so that you have consistent look whether the source code is seen in a terminal, in a browser window, in a text editor, or IDEs, because each one have slightly different settings, but spaces will consistently show up in all of them. And of course, most IDEs will help with automatic indentation, so make sure you learn the shortcuts and keystrokes in each IDE to automatically indent your code, and it should become a habit to indent your code just before you save it. Of course, it's very important to use a style checker to help you. All of the information technology companies like Google, Facebook, Amazon, Twitter will all enforce and mandate the use of style guides and style checkers. So ask your instructor about using style checkers so that you get in the habit of developing good, well-styled solutions so that you make a good impression the first time your colleagues look at your source code. Keep in mind, of course, it is you must be self-motivated to improve your quality and solutions. If you're simply relying on external motivation like points or grades or your instructor to enforce you to do good style, you're most likely in an incorrect major because you're saying you're not interested in doing good quality work by maintaining good quality in your solutions by formatting and styling. So if you do not do good quality work, your overall long-term success will be kind of muted and you will not be as successful as you could have been. Now let's look at the second aspect of good quality solution is to develop short, concise methods. Long, unfocused methods are basically hard to read, and these long methods show that you lack structured thought process and thinking about doing a well-structured solution. And of course, these long methods make software harder to develop, harder to understand, document, troubleshoot, and maintain. So ensure your methods are concise and focused. Typically, as a rule of thumb, you should keep your methods to be shorter than 25 lines of code. Keep in mind these 25 lines don't include comments or empty lines, but you should try and keep it under 25 lines of code. So as you develop methods, when you see your method becoming longer, refactor them into several smaller methods, into a series of cohesive methods. And you should do this first, in fact, before you even start writing code, is to kind of develop a skeleton for your program with comments and such, so that you have a very structured thought process and your overall solution and quality will be substantially better if you go through a methodical process of developing your software solution. And of course, use a style checker to help you here. Lots of companies again mandate style checkers and ask your instructor about using style checkers in your course so that you develop these industry standard practices right in college so that when you go to your jobs, you're already successful. And the third important aspect of quality is good documentation. Keep in mind each method should be documented using appropriate styles that are appropriate for that specific language. And documentation should show some example method calls, show some examples on how to call this method and what the return values are. That is the one that will really help your colleagues and your team to quickly reuse your solutions. And of course, keep in mind your colleagues and your companies do value documentation because it's very critical for maintenance. So keep your comments and code updated. In general, do not publicly post your solutions until you check with a style checker because the moment you put up poorly formatted or poorly styled code, it reflects negatively on your skills, particularly when you apply for jobs and your prospective employers go look at your solution at GitHub or other some public repository. Having a poorly formatted code is an immediate turnoff, and they may not even have you over for an interview if they see that you're not even able to put spaces or indent your code correctly. And of course, make sure your solutions are well tested to minimize bugs in your programs. So, testing is a very important aspect. Consider developing unit tests. If you're developing a full program, always do functional testing. A lot of college courses will use automated functional testers. This is because training you on using automated testing is very important. So, college courses will help you or force you to use them to ensure that you get training on it. And working with these automated functional testers really improves your learning and code quality. So, this is more for your own benefit, not for the benefit of an instructor. This is for training you to be successful in your future jobs. So, testing is important, so take it very seriously. And no one is going to be impressed in your future jobs if you say you have not done much automated testing. Automated testing is absolutely vital, maybe unit testing or functional testing. So you should get in the habit of doing automated testing and so that you're successful in your future jobs. All right, that covers the quality aspect of your jobs. Now let's look at aspects where you have to be proactive in order to solve your problems and deliver solutions in a timely manner. Technology can pose unanticipated challenges, particularly when you're picking up a new skill. You might experience a simple bug or a simple issue that, with experience, somebody could have troubleshoot very easily, versus you might be struggling to troubleshoot this issue. So, you might find adapting to these environments to be a little challenging, but the key idea is not to procrastinate figuring out the solution. First, give yourself enough time to seek help. So, when you're in trouble, you need to plan your time so that you can seek help from your colleagues or your manager or your instructor at your job. And of course, you have to ask for help when others are available. You can't be saying, oh, in the middle of the night I had a trouble and nobody was available to help. That's not how help works. You have to plan your time so that you can get help for troubleshooting your issues. Of course, your course or your work might use internal discussion forums, so make sure you work on your discussion forums. Of course, if you're in a college setting, you can ask your instructor to set up discussion forums for your class so that you can discuss some common issues and help out each other to troubleshoot those issues. And of course, you should proactively discuss any issues that you have with the instructor and boss. That means showing that proactive motivation troubleshoot issues shows that you're motivated to learn and succeed, may be in your college education or your job, and that is a very important skill to learn. So that covers some of the proactive aspects in your job. And of course, working as a team to troubleshoot issues is important. And occasionally, you should definitely help each other on discussion forums or to troubleshoot issues as well. But keep in mind, this is not to do each other's work, but just to help each other out a little. Given these four success skills, let's look at how jobs and universities tie in together. Hiring a new employee is always risky for a company. It just takes one or two people who can completely disrupt the flow of a product or disrupt a team. So, for companies, it is a lot of risk to hire a new employee. So then the question becomes, if how can we tell if an employee has the necessary background and skills to succeed? That means you can ask a question: is the resume of the employee legitimate? You can put any information you want in your resume. How do you know that those skills are real, and how do they know they're going to help you succeed in the new job that you're going to get? And even more importantly, some of the companies even hesitate to interview people because interviewing takes time away from the work that other people are doing. So even investing time into interviews is something that is risky for companies. And this is where the universities can come in to help. Over many decades, universities have built the trust that they're able to train students with the necessary backgrounds and skills, and the students have been challenged, and they have the skills to adapt and learn new or diverse tools and concepts that might be necessary for jobs. And of course, universities provide a systematic assessment of the skills. So, in some sense, your grades and scores from a university course reflect some of your abilities to adapt, learn new skills, and be successful at future jobs. Keep in mind, universities focus on multifaceted aspects. It's not just technology, it's communication, presentation, lots of different skills are done. And this is to focus on short, medium, and long term goals, where the universities would rather teach you how to learn how to fish rather than just giving you the fish for one day. So there's a difference in this philosophy that universities use to train students. And of course, all of the university training basically translates to risk mitigation for companies. That means when a company hires an employee, they are sure that this person has some of the basic skills that they need and they hope that people have so that they are successful at their jobs. And of course, this also requires that universities have to continuously update, deliver, and maintain good quality experience for all of their students. And this is to earn and maintain the trust with both the students and the prospective employers for the students as well. So universities continuously do this kind of a change as well. So here's a summary on being a good learner. First, learn to adapt to new tools and environments. So don't give excuses about like, oh, I could have done this in a different programming language or a different operating system, or I can do this in Eclipse and not in NetBeans, or I could do this in Java, not in C++. These are all excuses that nobody wants to hear about. Ensure you develop good quality solutions. Use automated tools. Tools and automatic style checkers and functional testers are the way to go. This is how it is done in the industry. Make sure you get expertise and experience in that. Make sure you deliver solutions, maybe homeworks or exams, in a timely manner. Delivering projects on time is very important. Make sure you proactively address any issues that you have and keep your manager or the instructor abreast of the issues that might be there. And of course, be a team player where you help each other to troubleshoot issues. But keep in mind, this is not to say you should be doing each other's work or to plagiarize each other's work, but to help them. So make sure you focus on these four key but often unsaid skills and ensure you try to gain experience on them as part of your university courses. Good luck.